Hello everyone, you're welcome to my YouTube channel. My name is Precious. We're going to be beginning the series on solving of Olympiad math problems. Okay, so you recall that generally the Olympiad problems and even some special exams such as GMAT and all of those interview exams, they're generally spread across the following areas. The first being the number theory. So they cover the area of number theory, and then we have the second as algebra. Okay, you find them asking questions in algebra, and then you have the third one, the geometry. Okay, so these are the three major areas where Olympiads bring their problems, okay, or examples or questions in their exams. Okay, and so we're going to be looking at different examples in different videos uh, uh, in this series. Okay, so now we begin with this one. It says we should evaluate this fraction. Okay, and you know that to evaluate a fraction, basically you just need to know what the denominator is, the numerator, and see if it can divide. If there are numbers, and if there are maybe alphabets that is involving algebra, you will know how to simplify. And then most important aspect of every fraction is usually the denominator, because if you can get the denominator, and of course if you look at the one we have here, you would see that the denominator is what we need to simplify. The numerator is already a single number, and then if we are able to find the value of the denominator, that would of course help us get the value of the whole fraction by just dividing the numerator by that denominator. And of course, you know that for Olympiad problems, there is usually the restriction of the usage of calculator. So you're always told not to use a calculator. So they expect you to do this without the use of a calculator. Okay, so how do we do that? Right now, and you can see what is being done here. The numbers are large, and so that's actually the trick. So they want you to use some theorems of mathematics to be able to solve this without dividing it, like normally. Okay, so what are we going to do? We'll start by, for the denominator, we'll try to see what is going to give us. So we'll begin by giving a name to these numbers, being that they are large. This dot here means multiplication, and here we have subtraction. So the subtraction will be a little bit easier. Here also you have a square. So how are you can see the square here. So how are you going to square this large number? That will take a lot of time. And so you are going to be needing at least some mathematical approach to be able to make that easier. So we begin. We say, first of all, at least we'll give one of these numbers a name. Maybe we start with this first one. So let's give that one a name. Maybe we call it n. If we call that n, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. So if you watch carefully, you will observe that the second number here is 1 less than this one. This one's ended with the 1, this one ended with 0. So that means that second number is actually n minus 1. Remember, we've called the first one n, while the third number here in the denominator is actually 1 more than the first one here. Okay, so that means that one will be n plus 1. Okay, so in other words, our denominator is simply equal to n squared. Remember that there is square on it, minus, you open a bracket, your n minus 1 is multiplying your n plus 1. Okay, so we will try to simplify this and see if it will give us something simpler. And so this is equal to n squared minus, if you open the two brackets inside, you are going to have, of course, this simply represents difference of two squares. Okay, so and that is going to give us n squared minus 1 squared, which is also 1. And then by the time you now open up the last bracket, you will have n squared minus n squared, then minus times minus 1 will give us plus 1. And of course, this n squared will cancel n squared, and so your whole denominator is now equal to 1. And you see that you have been able to solve your problem. So what is that going to give us then? It means that your numerator, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, is now being divided by, we have been able to simplify that the whole of the denominator is equal to 1. And you can check if this is actually true. So from what I did here, you saw that the whole denominator means n squared minus n minus 1 multiplied by n plus 1. Okay, so you can check whether this is equal to 1 at, for all numbers. You can try that using a number. Let's say 6. If I put 6 squared, then you will see that 6 minus 1 is 5, multiplied by 6 plus 1, which is 7. And so this is equal to 36, which is 6 squared, minus 5 times 7 is 35. And that's actually equal to 1. Try it with any other number. Let's say 10. So you will see that 10 squared minus 10 minus 1 is 9, multiplied by 10 plus 1, which is 11. So you will see that, 11. Of course, 10 squared is 100, and 9 times 11 is 99, and this is equal to what? 1. So you see that it works for all numbers actually. And then finally, by the time this is divided by 1, you will simply get your numerator, which is equal to option B. And that is the solution to this problem. You can check all other options. You will see that B is actually the answer. Okay, so this is our beginning of this series. Kindly subscribe to our YouTube channel, and if you love what we are doing, we plead with you please to like usually our videos. Whenever you come across our videos, please do like, do share our videos, and make comments, and that will always help the algorithm of our channel, and we will always bring you more content. We'll see you in our next video. Bye.